Okay, so let's take a look at the actual drawing I've completed so you can see where we're moving with this and what the next steps are going to be. Again, I've got mine diagonally positioned here. I've picked a difficult situation because if you can do the difficult one, you can do the easy one or the common one much easier. So what I'm going to do is I'm going to take this area here and I'm going to copy it over to another part of the drawing and then revise it so it becomes a simpler angle to work with. So I've done that here and I've taken basically the 4 posts and the beams. And the deck beams, some of them line up nicely, other ones don't, and this is simply to show you other lessons that are going to be coming very shortly. And I've done it in 2 directions. So one I've angled in 45 degree angle clockwise and the other one counterclockwise. And the reason I needed to do that is because you only have beams running in one direction and then posts or the ceiling joists running in the other. So in this particular case, the beams or the lintels are running north and south or up and down. I'm sorry, they're actually running east and west or left and right, and in this case they're running up and down, and then I dimension it accordingly. So it's very critical that when you make your sketch designs you understand exactly how you're going to put the project together. And when we go to the tables and charts for this, we also have to understand how we're supporting this. So here I have my brace, and this is something I was talking about a bit earlier, why are braces important. Well, if they're actually structural braces, then they actually can diminish the size of the span of the beam, which therefore means you can have a smaller size lintel member here. And I'm using beam and lintel interactively or interchangeably, and I apologize for that, but they're quite often used in the same terminology, especially with all the books you're going to, or the research you're going to be doing. But the lintel is 2-ply, beam is 3 to 5. So this structural brace, if it truly is structural, will actually remove the distance of the brace from the overall span. So without the brace, I have to take a look at the charts and select a 12-foot span. With the brace, I can reduce that by 2 feet on either side. So it would only be an 8-foot span, and you can see how that would substantially reduce the size of the joist based on what we did earlier in beam calculations. So I have that shown. I will be drawing formally the actual brace with detailed information. I'm going to be showing how this end cut actually looks with dimensions. You see dimensions here are all sorts of different sizes, but that's okay, that because of the viewport. And then I'm going to be showing also, and this is going to be a lesson all on its own, the different support mechanisms. Sometimes we'll have a pergola post on an independent column. Sometimes we'll have it on an existing beam, and if it's within a certain distance of a support for that beam, we can place it right on top of the beam. Sometimes it's actually part of the beam structure itself. So it sits on top of the beam on top of the post. So this is a deck beam that we can put a post right on top of. So I'm going to talk about all the different scenarios. I've drawn them on purpose to have all 3. You may only have 1 or 2 cases. So my final set of drawings will look like this. There is my top view, which reflects basically the same as on the framing plan, where the 4 posts are. That's all that I need to know on the framing plan. And then I identify the overhang of the lintel and the ceiling joists. I'll then identify the plan view of that, where the actual structural posts resides, what are the distances. I'll show the 2 different elevations because there are 2. One has the structural components as part of the post, and you can see how I've notched this out for my particular project, and the other one has the structural components from the side and the dowels and how they're attached, as well as the brace. Notice I don't have a brace in the non-structural direction, but I do have one in the structural direction, and it's to show the differences between the 2 methods. I show all the different base configurations, and then I also have a detail page which pulls all of this together. This is a detailed section, and this is all available to you. I'll be posting this online so you can see the notes that I would put in, how I draw it. I didn't include the Simpson-Strong tie actual numbers. You will, only because I didn't want you copying me. I mean, it's a bit of research you have to do. And then how we'll actually do calculation on the footing that's required for a pergola, as well as my offset post. This is the most difficult. I shouldn't say that. It's just a different detail from a common detail. And then my end cut detail, my brace detail, I have that all in plan. And this is where you're going to be leading with your final portion of this part of the project. And that will be due in week 11. So next week, week 9, your sketch design by the end of the class. And then you can start working, and that's what we need to do, is start working toward these drawings. And we'll have approximately 3 weeks, 2 weeks to the elevations, and then the third week will be all the little details that you have to apply to it. And then we only have 2 weeks left in the program, which finalizes this project. And so we do have sort of the end in sight. We're in the second half of this term, and so we must keep this pace going throughout the rest of the program. So that's all I have for you for now. Next week, be ready with your sketches, because we're going to be transferring those sketches. The lesson will be to transfer the sketch into a CAD project.